Hello again and welcome to session 2 of Econ 214. In this session, we'll be talking about the presentation of data, and I will first introduce you to the graphical methods. The aim of descriptive statistics, as I said earlier, is to present information in a clear, concise, and accurate manner. So we're going to illustrate how this can be done, but using tables and graphs. So by the end of this session, you should be able to organize data into a frequency distribution and then portray data by a histogram, frequency polygon, and cumulative frequency polygon, and also use other techniques such as bar charts, line graphs, and pie charts. So we'll cover frequency distributions, graphic presentation of frequency distribution, as well as other forms of graphic presentations. Frequency distributions. Now, when you have raw data, what is often called data is that the numbers are just churned out there. It makes very little meaning unless it can be organized in an informative way. And one way to do that is to put it in a frequency distribution. Now, a frequency distribution is grouping data into categories and then showing the number of observations belonging to each category. And the purpose is to condense the mass of data into a table that is more readily comprehended. Now, when you do a frequency table, what you do is to lose the individual specific values. But it also allows us to interpret the data in an informative way. Now, to construct a frequency distribution, there are some terminologies we must know. The first is class limits. Class limits refers to the inclusive values in a class of a frequency distribution. We shall illustrate this shortly. And there are two values, what we call the lower limit and the upper limit. And then we have the class frequency. It refers to the number of observations in each class. We also have what is called class boundaries. These are specific points separating adjoining classes. So they serve as boundaries between two adjoining classes, and they are obtained by subtracting 0.5 from the lower class limits and then adding 0.5 to the upper class limits. We also have what is called the class interval or the class width, and it looks at the number of measurement units or the range of values included in each class, and it's obtained as the upper boundary minus the lower boundary. You can also calculate it as the lower limit of a class minus the lower limit of the class preceding it. And then we have the class mark or midpoint. And this is the simple average of the upper and lower class limits of a particular class. So let's illustrate. Now you can see what I have in front of you. And let's say that the dean of the School of Continuing and Distance Education wishes to determine the amount of studying distance education students do. So he selects a random sample of 30 students and then asks them how many hours did you study this week, for example. Now, the numbers you see are the responses from these students, right? So this is called raw data. It's just been written there, and then you don't see any trend. You cannot make sense of it. But we can organize it into a frequency distribution. So what we do is that since we should have a number of classes, sometimes you could predetermine the number of classes. So let's say we want just to group them into 6 classes. So it means that we can determine the class interval, which we shall call I, and we're saying that to find the class interval, just look for the highest value in the raw data and subtract from it the lowest value, and then divide that by the number of classes that you desire. So from the data that we saw, the highest value is 36.3 and the lowest is 9.1. Now, because we want 6 classes, we obtain our interval as 36.3 minus 9.1 divided by 6. It gives us 4.53. We could approximate it to 5. So it means that that is the class interval or the width. So it means that for each class there will be 5 values or numbers included in each class. So let's say that given the data we have, we are starting with a lower limit of 8. We can generate the following classes, 8 to 12. And you see that it includes 5 values, 8 itself, 9, 10, 11, and 12. That's because we have the interval as 5. We can do similarly for the rest of the classes, 13 to 17, 18 to 22, 23 to 27, 28 to 32, and then 33 to 37. Now, what we do next is to prepare a table in which we write the various classes, and then what we do is to indicate the number of students who fall into each of the classes. So clearly, in our 8 to 12 class, there's only one. It means that only one student studied between 8 and 12 hours. And then for the rest, you could see the number of students studying for the designated number of hours. So for the classes 8 to 12 and 13 to 17, we can compute the class marks. We know the class marks are the midpoint or the simple average of the lower limit and the upper limit. So for the class 8 to 12, the lower limit is 8, the upper limit is 12. So the average of the sum of these two numbers is 10. Similarly, it is 15 for the second class, and so on and so forth. So this is what we call a frequency distribution. It lists the classes with their corresponding number of frequencies. We can also proceed to construct what is called a relative frequency distribution. In a relative frequency distribution, what we do is to divide each class frequency by the total number of observations. So this is what the middle column, or the frequency column, as you can see, is what we had previously. What we do next is to divide each of the frequencies for each of the classes by the total of 30. So the relative frequency for the first class, 8 to 12, is 1 over 30. Basically, what it does is to indicate the proportion of students or the percentage of students studying between 8 and 12 hours. And it continues for the other classes. So clearly, you can see that the majority of students are studying between 13 and 17 hours. That is 12 over 30. How do we represent the frequency distribution graphically? And that's what we turn our attention to now. There are 3 common ways in which we can represent a frequency distribution graphically. We use histograms, frequency polygons, and cumulative frequency curves, or what is called an ogive. So this is how you do a histogram. Now, based on our frequency distribution, there were 2 columns. We indicated a column for the classes and then a column for the frequencies. So a column for the classes are represented on the horizontal axis, as you can see. So what we've indicated as numbers are basically the class midpoints. But the class width starts from 8 to somewhere 12. But what we've actually indicated is the boundaries. So this is looking at the boundary, which upper boundary of the first class, which is about 12.5. And this is the lower boundary of the first class, and it will be 7.5. And then the frequencies are represented on the vertical axis. So what we do is to represent the frequencies in each of the classes by bars, and the height of the bars corresponds to the frequency in each class. So you realize that the class 13 to 17 is this, and it had the highest frequency of about 12. So it has the highest bar. So the height of this bar is equivalent to 12. And these bars in the frequency, in the histogram, must be adjoining. So this height is equivalent to 1, the frequency in the first class. This height is equivalent to 12, the frequency in the second class. This height is 10, frequency in the third class, and so forth. And this is how you depict a histogram. Another way is to use a frequency polygon. So you see that instead of using bars, we join the points made by the class midpoint and the frequency. So the class midpoint is 10. The frequency in that class is 1. So it gives us a set of points. So we mark it. And then when you come to the second class, the midpoint is 15. The frequency is 12. So this is the point marked. We do so for all. And then we join these points by line segments, as you can see. So the first point joining the second point by this line segment. The second point joining the third point by this line segment, and so on and so forth till we get to the end. And this just describes how the data is distributed, and it is referred to as a frequency polygon. Finally, we can look at the cumulative frequency curve. Now, in the cumulative frequency curve, what we use it to do is to determine how many or what proportion of the data or values are below a certain value. Now, what we do is to get a cumulative frequency, we add the cumulative frequency of the preceding class to the frequency of the current class. So that if you took the class 8 to 12, which is now being represented by its upper boundary here, the frequency in that class is 1. But the class preceding, we can think of a class preceding it, which has nobody in that class. So its frequency is 0. So when you add 0 to 1, it gives you 1. Now when you go to the next class, which is 13 to 17, the frequency in that class, as you noted earlier, was 12. But we are adding the cumulative frequency of the class preceding it, which is 1. So 12 plus 1 gives us 13. Now the frequency of the third class, which is represented by an upper boundary of 22.5, was actually 10. But we add to that 10, 13, which is the cumulative of the preceding class. So we got 23. We do that till we get to the last class, and the cumulative frequency for the last class must equal the total frequency. So once we've obtained this cumulative frequency table, we just plot it into a graph. Now you can see that on the horizontal axis, you represent the hours of studying, which can be done using the class midpoints or the upper boundaries. So as you can see, the midpoint for the first class is 1, so this is 1. The midpoint for the second class, the midpoint for the first class is 10, and we had only one person, so this is your 1. The midpoint for the second class is 15, and we had 12, so that is it. We had 12, but the cumulative is 13, so this represents 13. This represents 23, and so on. So you join line segments through these cumulative frequencies to get this curve. What it means is that when you pick any point on this curve, it can tell you the number of students studying less than a specific number of hours. Let's say you pick this point. It tells you the percentage of students studying for, or proportion of students studying for a particular number of hours. That is less than 20 hours. And sometimes it's possible to represent this frequency here rather by percentages. So you can just read off the percentage. So you will just convert this to percentages by multiplying the cumulative frequencies by 100. So it gives you the percentages on the vertical axis, and then you can read off. Now we want to wrap up our discussion of session 2 by looking at other forms of graphic data representation, or representation of data graphically. The first is the bar chart. Now, a bar chart depicts frequencies for different categories by a series of bars. So you have data and they are in various categories, and you want to represent each category by a series of bars to show how important each category is. So the data you see here is the data on the level of education and then the employment status of 37,038,000 persons. So because the data is measured in thousands, so this is the total. Now what we have done, the categories, is to group the persons into whether they are working, in work, they are unemployed, or they are inactive. And also another categorization is to look at their education status, whether you had higher education, that is university and above, A levels, other qualification, or no qualification. So each cell here, for example, the number 8224 or 8,224 is telling us the number of persons who have higher education and are currently working. But this number tells us the number of persons who have higher education but are unemployed. And then this tells us the number of persons who have higher education, that's 956, and are inactive. Now, that is when you move vertically. When you move horizontally, again, this is the number of persons who have higher education and are working. And this 5,654 or 5,654 tells us the number of persons with A levels who are working. 11,167 tells us the number of persons with other qualification who are working or employed. And then 2,583 tells us the number of persons who have no qualification whatsoever but are working. So this is the data, and in essence, the data is already summarized in a table, and this table is called a cross-tabulated table, okay? So we can represent whatever we want from this data by a bar chart, and this is an example. So you see we have 4 bars being represented here, and because we want to look at the education levels of people who work, so we are just looking at those who work. So among the people who work, we know that 8,224 have higher education. So the height of this bar is 8,224. Similarly, this is for those with advanced level or A levels, and this bar also represents the 11,167 who have other qualifications but are working. And then these are those without any qualification but are working. So you represent each of them by the bar, and the height of the bar indicates the number of persons belonging to that group. We can also go on to look at something slightly more complex, what we call the multiple bar chart where we want to put a lot of information on the graph. So here, even though we are still looking at the educational qualifications, we still want to look at it for the three categories of employment. Either you are in work, you are unemployed, or you are inactive. So for those in higher education, we have three bars. The first one representing those who are working in work. The second one, this blue or deeper blue, showing those who are unemployed. And the third one, which is in white, those who are inactive. So at a glance, you can see what is happening. Similarly, when you come to advanced level, you do it for the three categories of employment status. In work, unemployed, inactive. The same is done for other qualifications, and then no qualifications. So from a goal, this gives you a pictorial overview of the circumstance of these people rather than just looking at the numbers, which is meaningless. So it's a nice way of summarizing data. Now you can also have what is called the stacked bar. What it means is that we put bars on top of one another. So, for example, even though we still want to represent the three categories of unemployment, we don't put it side by side, but on top of each other. So we started off with a light blue, which is those who are in work. This again is the 8,224. And then we add on top of it the number unemployed, and then finally the third being those who are inactive. So the height of the complete bar includes the three categories. And let me backtrack a bit. When you go back to the table, it tells you the number here, the total here. So it's a 9,397 made up of 8,224, 217, and 956. So that is it. A similar thing is done for advanced level, and then for other qualification, and then finally no qualification. So this is a way to summarize data, and you know pictures are good. They tell a lot of story. By just looking at it, you know what is happening in the data. Now the stacked bar charts can also be converted to percentages. So instead of looking at the raw numbers here, we compute all of them, over 100%. So the total number in higher education, we know it, we make it 100%, and then we split it amongst the three categories: in work, unemployed, and inactive. So that's what we did. Now let me backtrack a bit. So if you want to if you want to look at what percentage this bar, the light blue here means, which can be read, it's slightly below 90% anyway. What you do to get that percentage is to look at this column, the higher education column, and then find that as 8,224, which is for in work and the higher education, divided by 9,397, multiplied by 100. It gives you that percentage that you are seeing here. You do it similarly for unemployed and inactive, and the total must be equal to 100%. Now, this is more meaningful because at a glance, what this graph is telling you is that those who have higher education seem to be more employed. In other words, those who have higher education, majority of them tend to be employed compared to those with advanced level and then other qualification and no qualification. What it means to you as a student now is that there are brighter prospects for obtaining a job from having higher education, because only about 50% of those without qualification, no, let's say no education at all, are working. But as you move through other qualification to higher education, the percentages increase. For example, we know that about 88% of those with higher education have employment, compared to about 76% for A levels, and then 50% for no qualifications. Now we will wrap up with pie chart. It's also a very nice way of representing data graphically. And basically what a pie chart does is we have one category and we want to allocate them to, we want to allocate a given set of data into different categories. And it is similar to the stacked, or what is also called the component bar chart. Now, the pie chart is depicted in circular form, and the circle is divided proportionally to the relative frequency allocated to the different groups. So, let's illustrate an example with the same set of data. Now, what we are doing here is that we want to look at those who are in work. Okay, we are just looking at those who are in work. But those who are in work, they either have higher education, advanced level education, other qualifications, or no qualification. So we want to use this circle to allocate to each of these four categories the area corresponding to their importance. So you realize that a circle is 360 degrees, right? So to indicate the angle that corresponds to, let's say, higher education, okay, what we have to do is to look at the number of people working but with higher education, divide it by this total, and then multiply it by 100. It gives us 107.2 degrees. So the angle for higher education should be 107.2 degrees. And you do so for the others until the sum is equal to 360, as it has been done here. So from a glance, or at a glance, you can know which category has a higher proportion of employed persons. Now, this brings us to the end of session 2. Thank you very much. I'll see you again shortly.